Hello and welcome to our sixth and final panel of the day with the subject of looking ahead, what do 3D printing applications hold for the future? I am very happy to be surrounded by these amazing individuals, Edward Davis, Milad, Nikokar, Felix, Ewald. Thank you so much, guys, for being here. Very appreciate it.
Thanks for having us.
Thank you so much for having us.
Yeah. Well, thank you for being here. Just a quick rundown. Most of you guys will probably be familiar with the gentleman already, but just for information, Edward Davis is the strategy director of digital manufacturing and 3D printing ecosystems at HP. Milad Nikokar is the additive manufacturing technical lead for Facebook, and Felix Ewald is the CEO and co-founder of DyeMansion. Gentlemen, before we jump onto the subject itself, I think it would make a lot of sense if we can do a quick rundown, and each of you guys can tell us a bit about you and your connection with additive manufacturing. Edward, do you want to start?
Sure, thanks. So I'm actually been at HP a very long time. My background is mechanical engineering, and I'd been working as a product developer and program manager in 2D printing until around 2008. I started working on 3D printing. We saw it as a new opportunity for us. I ran a program. We did an OEM with the Stratasys product in 5 countries in Europe to kind of learn the market. Once I got that program introduced, I started leading the team that investigated and eventually invented the multi-jet fusion technology. And after doing that, I transferred into HP Labs organization and took more of a strategic role. So that's me in short. I've been in 3D printing now done about 12 years.
Nice. Milad?
Yep. So first of all, again, thank you for having us, for the opportunity. Really looking forward to our discussion today. My name is Moab, and I have been in additive space since 2011-12. I kind of started my graduate studies in additive, and then joined a variety of different companies, primarily focusing on material development for powder bed fusion technologies. So worked in different applications, worked with Evonik as a material provider, and developed some material there for some different applications, including medical. And most recently, I was a part of the materials team in EOS down in Texas. And I have been with Facebook for about 1.5 years now, and I'm leading the additive efforts here in Facebook infrastructure. And that is the part of Facebook that is mainly focusing on developing hardware gears for the next generation the data centers that we have. And if you know about Facebook, is basically we are building our own data centers, and we are designing all the gears that are going there. And we have been doing that since a few years back. We also have a few different consumer goods electronics that they are also benefiting from additive in terms of prototyping and just pushing the boundaries and coming up with the next generation's higher performing hardware.
Fair enough. Very interesting. Thank you. And Felix?
Yeah, hello everyone. So I don't have that much experience. So basically, straight after my studies, I founded DyeMansion, co-founder. And basically, in the beginning, our idea was to sell 3D printed smartphone cases. But we recognized quite soon, after we sold the first 200 cases, that the color from the dyeing process went off and colored the pants of our customers. So that was a big shit for us. And we had to make a decision: quit 3D printing or develop our own coloring solution. And that's what we did. So after 6 months in our basement, we were able to achieve at least a stable black. And then we wanted to sell smartphone cases again, but we met someone from EOS, and he told us that smartphone cases are maybe the most boring application that you can do with 3D printing, but the quality and the surface finish and the color of our smartphone cases is super great. And if we want to switch our business to developing post-processing solutions, we would ask Dr. Langer to give us the first money, the founder of EOS. And basically, that's what happened. And since then, we are developing post-processing machines. We call it our print-to-product workflow. And so far, we sold around 500 machines. We are 80 employees, and we raised around $23 million in venture capital.
Impressive, to say the least.
It sounds cooler. Instead of saying switch your business, say that we pivoted. We pivoted.
Pivoted.
Yes, exactly.
To the people viewing the panel, I would just like to remind, much like all the previous panels, there's a Q&A box at the top right. Please do feel free to bombard it, because it's not every day that we have the chance to speak with the three experts we have today. So obviously, our topic today, 3D printing applications and what they hold for the future. I'm pretty sure we could stay here for hours and hours and go over them. So what I recommend is, let's try to go over certain basic things, and then let's just unleash the Q&A and really make the most out of it. Okay, so let me just start with a question I pretty much always have, because it's been stuck in my mind for even before I got into 3D printing. And this is a concept I think most of us are familiar with. So, Star Trek introduced to the world the Replicator. The concept of the Replicator, as we all know, is pretty much that it would replicate something. And I think based on that, for many years to come, decades after that, there was always a thought of how a machine like such could take the place in a household, much like others have done over the years, like a personal TV or a microwave and so on. We're in 2020 now, and I think we have quite a bit of experience with 3D printing. It's become obvious that it's not a case of each individual owning a 3D printer, rather than mainly using 3D printing for production and more, serial production and prototyping, as you said, etc. My question is, we've started mainly with prototyping, and we are gradually moving from that to low volume production and perhaps higher volume production and such. How do you guys see this linear movement of gradual change? Ed, do you want to start?
Yeah, let me go ahead and start it. You know, I've been listening to your event. It's actually quite interesting. So let me say that first, the applications are difficult to say what are going to be the applications, but I can put them in categories, and everything that we said up until now, I think, is going to fall into these categories. The first three categories are things that we can do today, and you hear a lot of it. The first one is low volume applications or low volume use cases. As you've heard this morning, assembly line tooling, as you just heard in your last event, customization, they're in that category of low volume. The second category, and people don't call it this, but what it is supply chain disruption of singular part products. And when I say supply chain disruption, I mean creating a more efficient supply chain for singular part products. And an example of that is Smile Direct. And so these disruptions happen when you have a long and expensive supply chain, and Smile Direct has interrupted that supply chain, but it's a singular part product. And to emphasize that, I always like to say, people say, well, yeah, what do you mean singular part products? What I mean is you can't do that with something as simple as a food blender. A food blender has a cast metal part, it has a sheet metal part, it has a PC board, it has rubber, it has color plastics, it has clear plastics. You can't print a food blender. And so it's not in that category, and you can't disrupt that supply chain because you've got parts coming from at least 8 different suppliers, right? And so that's that counter example. You can't do multiple part product disruption today because you can't print that. The third category is complex geometries. And complex geometries are in particular interesting in metal for lightweighting. but also in plastic, complex geometries are not breaking things into injection moldable parts. And very often things like fluid management systems fall into that category, where it's not just a complex geometry, but higher performing. And then the last three are new ones. And these categories are ones that require additional thought or additional development. The fourth one is what I call hybrid supply chain, which I think I talked about in your marathon in March, where you create a different supply chain that has both agile and lean, and for the same part, you have a mold for the part and you have a 3D printed version, and you use them to create a push-pull supply chain. And then the last two categories come down to new materials. The first, there's new solid materials, and you see that new solid materials like the embedding of carbon fiber into some of these material extrusion machines can literally take the place of aluminum if you can get the characteristics of aluminum. And then the last category, which is the most complicated, is multiple material parts. And on that one, I think that the leading contender for multiple material is actually the embedding of electronics, which then begins to start the possibility for disrupting those supply chains for things like food blenders. And so those are 6 categories. And then I think all of our applications fall somewhere within those 6, and I almost explain them in the order of evolution.
Yeah, you've clearly put some thought into this.
Yes, definitely. And so if I kind of just, it was very refreshing to see, like, I had, I guess, 3 or 4 of them also kind of like on my list, just kind of like sitting there and thinking about how far we come with additive and where we are going from here and what the future might hold. The 2 important ones that I want to kind of like stand upon and I guess eventually merge them together is the complex geometries, or as I call it, like improved performance. Yes. And these are the things like lightweighting. These are the things like performance improvement. In our case, like we are doing a lot in heat exchangers or cooling solutions or things like that. So that I think that we have come a long way with additive, and but still there is a lot of room for improvement, and that will be mainly derived by the design. And I don't think that we are still pushing the boundaries that much to gain a significant improvement over the conventional manufacturing. Because when you come at the end of the day, additive manufacturing, or we have to kind of like come to grips with that reality that additive manufacturing is a little bit slower and more expensive technology compared to many of the conventional manufacturing. And we have to kind of like offset that negative point with that wow factor that, okay, we can design a part and we can unleash this design freedom or 3-dimensional geometry freedom that can introduce like a 50% performance improvement compared to a lot of the conventional manufacturing. And then only then we probably might have a shot to break the glass ceiling and go from prototyping into a viable industrial solution. And that will take us to another point that Edward mentioned, and that is the supply chain. I would call it like an ecosystem. So companies have been starting to do that, just making faster machines, fully automated machine. But comparing to the competitive technologies, we are nowhere close to having a full ecosystem of the solution. So if you even have like a good prototype today, you manage to kind of like really push the design, come up with a good prototype. It's not something that you can easily take to a company or a partner to make it into the scale. And I'm going to use the same blender scale that Edward used. When you talk about some of those day-to-day kind of like consumer electronics, they are the volumes for that are in terms of like millions. And that is one of the pieces that we have been at Facebook going like head-to-head, trying to establish that ecosystem. But you have multiple players that holding the pieces of the puzzles, and I guess for all those players have to kind of like come together and offer the solution. Because in a lot of the competitive technologies, for example, in the CNC machine, if you have a prototyping CNC made part, it would be very easy to take it to a partner somewhere halfway across the world, and they have already this full ecosystem of DFM, production, prototyping, QC, even shipping and packaging already figured out, and they can just take that part and run with it. But that is not something that is established for 3D printing as of yet.
Thank you.
Yeah, guys, you already mentioned, I guess, so many things. I'm not sure if I can add something, but maybe because always the first slide in my pitch deck when I talk to investors, maybe I can sum up everything in my words. And so basically, when I look at 3D printing, and I mean, you asked for how 3D printing will grow in the future. I think right now there are a lot of low volume applications, and I think this is important. But when we really talk about future growth, 3D printing has to deliver advantages that other technologies are not capable of. And there, I look at two sides. The one side for me is the product side, as you already mentioned. And there, with 3D printing, we can create superior products with very high value. And the one thing is to have increased performance because we can produce complex structures. And the other thing for me is customization. So my eyewear frame is 3D printed. They scanned my face. And so they really customized this frame to me. And so for me, this is a super huge value. So this is for me the product side. And the other side is the supply chain side, where 3D printing can have a huge impact. And basically, you also talked about Star Trek. I mean, with 3D printing, we are able to send products via email, and we can produce them on site and on demand. And there we have an application as example with Daimler, where we produce 3D printed spare parts, and we kind of realize the digital warehouse together with them. And basically there with 3D printing, we just replicate the injection molded parts, and we start with buses and trucks because they need the spare parts, they need to deliver it for 40 years. And so they use 3D printing there for, of course, only small quantities. But this really shows the potential that we have on the supply chain side. And maybe to come back to the low volume side, I think we shouldn't underestimate the potential on the low volume side, because when I look at the injection molding market, I mean, compared to 3D printing, this is just so huge. But 10% of the injection molding market is low volume, actually. And low volume in injection molding means 10,000 parts or less. And so if we are able to bring down the costs with 3D printing, all applications will benefit from it, but also the market, just the low volume market in injection molding, which I think is a market that we can target with 3D printing in the next 5 years, is so huge that also, we just shouldn't underestimate the potential also from the low volume side.
That's actually a very interesting point, and you're giving me a nice pass here, because one of the things I would like to cover is how a technology family, I guess, like additive manufacturing, how it coexists with the other pre-existing technologies of manufacturing. Because correct me if I'm wrong here, but I feel like there had been, and I'm using past tense because I don't think that's the case anymore, but I think it had been a notion of 3D printing versus injection molding, 3D printing versus CNC. And I personally felt like there was a bit of an extra level of competition there. And as you very nicely said, Felix, often it's not the case necessarily that they go directly one versus the other. There have been cases where they can be complementary to others. And frankly, to take 3D printing today in order to produce something that you will injection mold in the millions probably doesn't make sense, and perhaps it might not in the coming future, in the near future. I guess my question is, how do you see technologies coexisting together, and how do you see the role changing over the years? Have they gone from competing to complementary to each other? What's your experience on this?
Yeah, can I start again? Those 6 categories that I mentioned are actually categories that don't suit injection molding very well, right? And this is why 3D printing, as Milad mentioned, is generally not as productive and generally results in more expensive parts than you're going to get from injection molding. So it's actually a ridiculous proposition to try to compete for the exact same thing. It's a complement. And we're used to all of these parts that we're talking about for 3D printing, but if you look at the world of making plastics, there's lots of different ways of making plastics parts. It's not just injection molding. There's at least 20 processes: thermoforming, laminating, extrusion, et cetera, et cetera. Everything finds its market position. So I think our actual realistic objective is to be one of the menu of options for product designers and supply chain managers to choose from.
It's a good point. And in regards to what is to come in the future, because there've been projects now. I was not so long ago when we could travel. I was at a show where I remember speaking with an automaker where they were showing us how in their engine now it's gone to the point where before they would use just a single technology type. Now they had combined 3D printing with some CNC machine parts, with some injection molded parts, because it's the same used in all of their cars, in all of their models, and so on. And this was in 2020, maybe 19. What about in the future? How does that evolve?
In the long term, we actually need to see improvements in the 3D printers, and it's those last categories, the complex geometries, and including embedding of electronics into parts, actually will then be starting to take money and business from other processes, because you cannot do that with the traditional processes. Now, what has to happen is we need to invent all of this multi-material functionality, but at the same time, and I think Milad alluded to it, the design tools need to change, and very specifically, we need to move towards generative design tools that really facilitate complex design thinking. And the current CAD tools, their boundary representation, it is very hard even to make complex geometries with the current CAD tools. And so evolution of design tools and 3D printing is what's really going to open up taking a broader market from these traditional processes.
Yeah, I totally agree with that. And just to kind of like segue back, like Felix was mentioning that, okay, if we were able to kind of like bring down the price of the technology. So the way I see it, that's a big if, and I don't think we will ever be able to compete price-wise with the traditional manufacturing methods, because just the rates and the prices of those, and they have been like around for like last 30 years, so they have been optimized over and over again, and cost reduced, and reliability and everything else. So that's I'm not saying that we don't have to pursue that, and actually that is going to be probably the 50% of the efforts going to be down the route of reducing the cost of the 3D printing manufacturing. And there has been some tries, but the general approach of kind of like some of our friends in the machine manufacturers, they said like, okay, we had this $2 million piece of machine, now we're going to have another like $1 million robot on it. So that approach, it's kind of like we need to probably put on a different kind of like a glass and look at it as a different angle to reduce the price of the additive manufacturing. But that's of the effort, and knowing that and accepting this reality that we probably not going to be able to compete directly on the price with some of these mass production manufacturing methods is really important. But that doesn't mean that additive is going to be like they don't have a shot in making it to mass production. I think that extra price that additive will add over like injection molding or compression molding or whatever the process that is, that can be compensated by adding the functionality. We can, and by just making there are many different avenues, lightweighting being one of them, printing semiconductors, electronics, and consolidating assembly parts being another part of it. So that would be the other kind of like piece that will take us to a specific and unique position, and to kind of like have the right amount of application, the right amount of offering at the right price. That price is going to be slightly higher than your traditional injection molding or traditional like other kind of manufacturing. But when you offer that extra, that kind of like capability or that reduced assembly by kind of like compiling these assembly parts together and making it one part, when you put these two together, then it would be something that we definitely have a shot, and that would be something that companies and engineers would buy into that. So I guess just knowing that where we are and where we are kind of like hoping to kind of like shoot for, that is something that additive community as a whole has to kind of like come to grip and understand.
Thank you, Milad. Thanks a lot.
What I would
Felix,
what I would like to add, I mean, you're totally right with design capabilities. I think there is huge potential, but also I think one thing that is happening right now is education. So I think it's super important. I mean, 5 years ago at a university, no one know something about 3D printing, and I think when this is changing right now, and when people are learning not only how to design parts so that they are easy and cheap to manufacture, but really understanding the potential of no design limitations anymore, I think this will definitely accelerate the development of 3D printing. And I mean, what Milad said is of course right. There is extra value with 3D printing, and this is the go-to market for the next years. But still, I think we also should be ambitious, and I think costs will be a big driver, because when we look at the applications with our customers, when they think about producing millions, and there are those ideas and their applications, it's definitely about the price. And so I think we all together should also be ambitious on bringing down the costs. I know there is a lot of other potential for 3D printing and higher value and everything, but in the end, I hope that in the next 5 years we will see those applications. We already see the first applications, but I think a huge accelerator will be if we are able to bring down the costs.
For sure, yeah. No, it's.
I think of that, Felix, rather than drivers, it's the minimum right to play. You actually have to be cost competitive. Now, having said that, I'll go back and I'll agree again with Milad. Anybody who thinks that injection molding has opportunities for more cost efficiency doesn't understand injection molding. To give people a reference, most of the cost of an injection molded part is the material cost. Around 65% of the cost of an injection molded part is the material cost, and the material cost between $2 and $5 per kilogram. That's incredibly cheap. This process is just, it's been optimized for 150 years for cost efficiencies and productivity. It's very difficult to compete against that one-on-one. So it does come back around to designing in a higher value, as Milad suggested, or even combining parts into this complex geometries, where instead of comparing your cost to one injection molded part, you compare the cost versus 5 or 6. So clearly cost is a driver, but it's more of a right to play than a vector, strategic vector.
Absolutely. And if I may kind of like quickly expand on the design thread a little bit. So there are like two different, for that one also, there are like two different pieces of the puzzle. That one part is held by the design engineer, regular folks at any companies, that they know their application and they know what are they looking for. And the other piece is usually held by the manufacturers, by the people who know the process, and that is more aligned line of like DFM. And both of them need improvement, because from what I have seen, and there has been a lot of efforts along those lines, but on the design piece, most of the time there are like two people sitting there on a CAD software and so like, okay, what if we put this one on, or what if we can? It's so manual. So if we can kind of like automate that a little bit, generative design, I've seen companies trying to harvest the capability of like organic design, artificial intelligence. That's definitely a route to go, and kind of like taking it away from these tribal knowledge of, okay, you have an engineer that has been working and trial and error for 10 years on additive. Now he has like a library of things that work and like things that doesn't work. And that is not very often you see that in additive work, just given the technology being newer and the workforce being a little bit limited. So that piece definitely needs improvement, and a lot of companies are trying to do that, which is really appreciated, but we need to accelerate on that. And the other piece of it is the DFM, that the manufacturers, the owner of the process, they have to kind of like, automating that would be a big goal, but having, a lot of these already happens, having to partner with the application owner, with the customer, to bring it down, the price of the material, the process, increasing the packing, and like a lot of different factors. You just kind of like, you people, you know better than me that just by adjusting your layer thickness, just by adjusting your scanning strategy, your time per part, and eventually your cost per part can dramatically go down. So that design piece, I guess it's one of the important pieces of the puzzle.
Milad, if I may just jump in here, as expected, time is flying, so I want to incorporate some of the Q&A as well from our audience in the conversation, because frankly, we only have about 15 minutes left. So I'll try to dig into those, and by all means, if there is anything else that you think of, feel free to raise it too. But at the moment, the most upvoted question is directed to yourself, Milad, and I think it's an expected one I've heard quite a few times, which is basically, can you please comment on what Facebook will be doing with additive manufacturing?
Yes, absolutely. So as I said, with the demand increasing by day-to-day operations, number of users, your pictures or videos that you're storing on cloud and on your social media, kind of like increasing the resolution, we are seeing exponential growth in the demand. And that drove Facebook to start making our own data center or our own hardware gear that are going into the data center, simply because nobody else in the world had the problem, so nobody really cared to solve it. So we said, like, okay, it's kind of like our own destiny, so we have to drive it. So since a few years ago, we have been starting to develop our own hardware that are going into our data center. And that is anything from like a small heatsink, heat exchanger, all the way to the full rack. So that is one of the areas that we are now getting the end of the road on some of these cooling solutions, especially like the air cooling solutions. The power dissipation is so high. The power of these chips and these CPUs and GPUs are so high that we are now, traditional manufacturing methods, we just simply won't cut it anymore. So that's one of the areas that we are experimenting with new technologies, additive included. And also on the similar scale, we have a line of consumer electronics, virtual reality headsets and gears that they are also kind of like using additive for product development, for performance optimization, and things of that nature. So that's kind of like a nutshell.
Thank you, Milad. Now, Felix, earlier you mentioned, you spoke quite a bit about cost and cost reduction, which is, I guess, is one of the main typical limitations that 3D printing can have. As Ed said earlier, it's inexpensive. Then, one of the most voted question is, what is the main limitation that you think global adoption of AEM will have in the industry? And as an example, he or she has materials, lead time, building volume. What would you say?
That's a very good question, and maybe one of the hardest to answer. What are the limitations? Because there are many things that need to improve. Yeah, it's increase of technical capabilities, and with that I mean reproducibility of the whole process, material availability. That's the one thing. Then, as I already mentioned, is really automating the whole process, bring down the costs. But then there are, the things like education, design capabilities. For me, there is not the single thing that we have to improve. It's just a complete new way how we produce parts and products. And in my opinion, the most important thing is just time. Yeah, I think we all need to have some time, and time will bring some great progress. But it's not, for me, it's not really, it's super hard to answer this question with one word or something like that.
Which is fair enough. And about time, because time is a tricky term. If we were having this conversation 10 years ago, obviously it would have been completely different. I cannot stop but think that around a decade ago is when a variety of 3D printing patterns expired, which is when the market really opened up and the competition started bringing up new technologies and innovations and ways of producing. And if you think about it, since then, just so much has happened, just an endless pool of things in terms of development of materials, applications themselves, technologies, and so on. And that has brought us to today, where, as we've all agreed, there's still so many different things that we want to improve on. If we're having this conversation in 2030, what do you think will be the milestones that we would cover in that next decade? What sort of applications do you think that we will be able to talk about? Ed, maybe you want to take this one?
I'm always looking for the future trends. So what we've seen
once again, an easy question, right?
That's why we have you guys here.
What we've seen is, as you said, the major patents expired for the Stratasys FDM, major patents that expired for laser sintering, laser melting, and what we see is mass innovation. Everybody wants to take the opportunity to go in there and innovate. But what we've also seen is a proliferation of companies, and the market has not grown that much. And so I think, and let's put a mark on the calendar, 2030, we're going to see between now and 2030 a consolidation of how many companies are actually successful in this. I think it's good to have the mass innovation. It's actually great for the industry, but not everybody's going to survive. And I think those that do survive will be ones who have a technology that provides a performance that you cannot attain from other processes, right? As Milad keeps on alluding to, look, if you can't do it with injection molding, or you can't do it with another 3D print technology, that's your market. that's sticky. That's very sticky. And so I think rather than just invent another laser sintering machine and another laser sintering machine and another laser sintering machine, the companies that are going to be most successful are those that have a unique and relevant differentiation. And that's who we're going to see at this table in 2030.
Fair enough. Felix, is there something you want to add?
It always, when Ed is saying
it's one
something,
of the questions you
I
like.
only can agree.
We should have different speakers next time. We'll bring people that you disagree with.
No. But I mean, actually, Ed is right, and hopefully, I'm still here in 10 years because then we have been a successful company. That would be that is one part of my vision. No, but I think for me, our vision as a company is that 3D printed parts become part of our everyday life. And what really excites me is if I walk around here in Munich and I see 3D printed parts. That is what really excites me. And what maybe sometimes excites me even more is if I talk to those people and they have no idea that it's 3D printed. And I'm just curious. I'm also super curious what will happen in the next 10 years, but there are a lot of exciting things, and sometimes we shouldn't underestimate how fast things can progress. Of course, right now, and I mean, I'm doing this, I'm in 3D printing now for 7 years. That's maybe not as long as Milad and Ed, but still, sometimes it feels like it's already forever. But when I look back, what happened in the last 7 years, I have to say it's huge, right? It's also huge. And so honestly, I have no idea what will be in 10 years, but I'm very much looking forward to the journey.
Well, one thing that excites me is that 3D printing is not just a cool technology that can do one thing well. It's just an ever-growing family of technologies that can influence just so many different markets and so many different applications. Obviously, we've seen the aerospace and the medical and the consumer goods industries being disrupted, I guess is a good term, and so on. But again, there are just so many things that are happening, and I cannot stop thinking of that, let's say, 10-year mark, because on the one hand, it might sound futuristic now, but as you said, Felix, you started 7 years ago, and it probably felt so quick, and at the same time, so much has happened. So have you guys, from your experience, from your careers, have you seen any fundamental milestones in terms of something that is not yet the case today, but will be in those 5 to 10 years moving forward? And it can be obviously in whatever industry you want.
Yeah. So, if I go back to that last category that I mentioned in the beginning, we have not even begun to see multi-material applications. And I honestly believe, I'm a mechanical engineer, and I'm having a hard time. I'm struggling with why I would want gradient mechanical properties, but I can think of a million applications for electromagnetic manipulation in a part, or electromechanical parts within a part. So I think
there's your market, as a wise man once said.
Quite honestly, I think that's going to be the first multi-material applications are going to be multi-material electromechanical. And there's all kinds of things that you can do with that. Anywhere from radar domes, where instead of making them out of a solid material, you can actually focus the radome. Is electromechanical. Sensors, micro electro mechanical systems. I think we're going to see this as probably the first multi-material applications to really take off. And it does require innovations in the CAD systems, because today mechanical CAD systems and electrical CAD systems don't talk to each other. They're not one system. And so we're going to see a blending also of electrical and mechanical CAD and simulation tools come together.
That's a very good point.
So let me just add here, kind of like a slightly different. We're always just kind of like thinking about the like what it would look like in 10 years. What I would like to see in the next 10 years. That would be if we have, as just kind of like repeat that ecosystem thing. So if we had ecosystem, full ecosystem of 3D printing, that would be the major piece and major kind of like thing on my wish list. Because today, in terms of like the limitation on the design, on the material, on the machine, it's not straightforward, but you can, if you look hard, you will find people that they are kind of like having those pieces of the puzzle, good material, good application. But the major holdup now is that full supply chain of, if you have a good part, if you made a good part in additive now, today is not possible to kind of like have it shipped to like so-and-so company, and they will just take it, do a minor DFM on it, and quote you for like 100,000 parts per year or 1 million parts per year. So that is that would be kind of like one thing that I would like to see that happen in the next 10 years. And obviously that is one of the things that we at Facebook are working toward that, and would like to kind of like make that happen and take these 3D printing from production, low volume production / prototyping environment to a fully mature technology that can make parts into scale for many, many different applications.
Great, thank you. Gentlemen, we are pretty much running out of time, but I recommend, shall we do a very quick run through another couple of questions? Just quick question answer, and then we can end the panel. One is a question from Alex, rather a specific one, which is, will graphite be printable at some point from your experience? And if so, do you think it will be a game changer when it comes to functionality and interaction with the body?
I would say, if we're gonna like take a stab at it, I would say yes, but for graphite case is the same case as like organ printing, right? The mechanics is there. You can put the graphite like in whatever format that you want. But as you know, a graphite molecule is a planar molecule. And really, when you want to make it into the three-dimensional, the interaction and the bond and the activation between two graphite plates, that is really the holdup now. And that won't happen until some of these companies that are experts in graphite will kind of like start working at it. But I think the mechanics of it, it shouldn't be very hard. There are many 3D printing manufacturing methods out there that they can make can give them a powder, and they can make a three-dimensional geometry for you out of that.
Fair enough. Thank you, Ewald. Next question is, what role does AM is going to play in the transition of the automotive industry from fossil fuels to more eco-friendly sources of energy?
So
questions up for grabs.
Yeah. So if you look at electronic vehicles, it's moving from a mechanical device to a more electrical device. So I'll keep on harping on electromechanical integration is part of the potential for 3D printing to help advance that market. The other one is that these batteries weigh a ton. So lightweighting in automobiles is still a very, very important vector to push on. So I think a lot of the 3D printing technologies that can help with lightweighting existing structures, and that could be metal, or it could be what I mentioned before, replacing metal with a new plastic material that's lighter than the metal, but as strong.
Fair enough. Thank you so much, Ed. I think at this point now, guys, we've officially run 5 minutes late. So I think it's a good time to wrap up the panel. I'm sure there was so much more that we could discuss. To all our viewers, keep in mind we have our after party in a sec. So Felix and Milad will most probably be joining us with their drink. So feel free to question them, but not so much really. Let's try to keep it casual, and I'm sure we can connect with each other through LinkedIn, emails, and other ways of communication. For now, I would just like to really thank you, Ed, Milad, Felix. On behalf of 3D Natives, we very much appreciate you taking the time and answering all these questions. And I'm sorry if some of them were a bit difficult to answer, but when we're speaking about the future, it's always unpredictable.
Oh, thanks for having us.
Thank you. I hope in 10 years we will be speaking here at Additive Digital World 10.0 and have the exact same panel.
Exactly the same panel.
All right, put it on my calendar.
Awesome. Well, cheers, everybody.
All right, ciao.
See you.